Welcome back. In the previous video, we discussed about Zeeman effect, Zeeman shift, types of Zeeman effect, differences between normal and anomalous Zeeman effect, and experimental arrangement to observe normal Zeeman effect. In this video, I'll be discussing the theory of normal Zeeman effect on the basis of vector atom model, and hence I'll be deriving the expression for Zeeman shift in terms of frequency and wavelength. We know that the total angular momentum of an electron is due to the orbital motion and spin motion of the electron. But normal Zeeman effect is observed in only those atoms which have even number of electrons whose net spin momentum equals to 0. Therefore, if we neglect the spin of the electron, the only angular momentum is due to orbital motion. I have represented the orbital angular momentum of the electron by the letter PL here. So, the orbital angular momentum is quantized, hence we have PL is equal to L into h by 2 pi, where L is orbital quantum number. The corresponding magnetic moment is given by mu L is equal to minus L into EH by 4 pi m. Rearranging this, we have minus E by 2m, L into h by 2 pi. L into h by 2 pi is nothing but PL, so mu L is equal to minus E by 2m into PL. The vectors PL and mu L will be perpendicular to the plane of the orbit. When an external magnetic field B is applied, the vector PL will start precessing around the direction of the magnetic field as shown in this figure. So, magnetic field is applied in this direction and the orbital angular momentum vector is here. This will start precessing around the direction of the magnetic field. So, in 3 dimensions, this will be like a cone. This precession is called Larmor precession. The effect of this precession is to change the energy of the system by an amount dE given by omega L PL into cos theta, where omega L is Larmor precessional velocity and theta is angle between PL and B as shown in this figure. The Larmor precessional velocity is given by omega L is equal to EB by 2m. Rearranging this, we have omega L PL is equal to minus mu L into B. Therefore, the expression for change in energy becomes equal to minus mu L into B into cos theta. So the projection of orbital angular momentum vector on the magnetic field direction is given by PLZ is equal to PL into cos theta. This you can see in this figure. Also, PLZ is equal to ML into h by 2 pi because the z component of the orbital angular momentum vector is quantized. So ML is magnetic orbital quantum number. For a given value of L, ML can have 2L plus 1 values. So combining these two equations, we have cos theta is equal to PLZ by PL or ML by PL into h by 2 pi. So substituting equation 2 in and equation 7 in equation 4, we have the change in energy is equal to minus mu L into B into ML by PL into h by 2 pi. Substituting for mu L here, the equation and rearranging the equation, we have dE is equal to EH by 4 pi m into B into ML, or dE is equal to EB by 4 pi m into H into ML, or dE is equal to mu L into H into ML. So mu L here is the Larmor frequency given by EB by 4 pi m. So this equation shows that each energy level of the undisturbed state of the atom splits under the action of external magnetic field into sub-energy levels. Therefore, if E0 and E are the energy states of an atom corresponding to an orbital quantum number L without and with external magnetic field respectively, then E is equal to E0 plus mu L into HML. So mu L into HML represents dE here. Similarly, for another energy state of the atom corresponding to orbital quantum number L dash, E naught dash is equal to E naught dash plus mu L into H ml dash. Under the influence of external magnetic field, each of the above levels split into 2L plus 1 and 2L dash plus 1 subenergy levels respectively. When the transition takes place between these subenergy levels, the frequency of the line is given by mu is equal to E dash minus E by H, or this simplifies to mu is equal to nu naught plus nu L into delta ml. Nu naught here represents E naught dash minus E naught by H, and delta ml is equal to del ml dash minus ml. So not all the transitions are possible. Transitions are according to the selection rules. Delta ml is equal to 0 or plus or minus 1. Therefore, the frequency nu will be equal to nu naught when delta ml is equal to 0, nu is equal to nu naught plus nu L when delta ml is equal to plus 1, and nu is equal to nu naught minus nu L when delta ml is equal to minus 1. So in this figure, this line represents the transition when there is no magnetic field, the transitions from E naught dash to E naught level, or L is equal to 1 level to L is equal to 0 level. In the application of strong magnetic field, the level E naught remains the same because for L is equal to 0, ML is also equal to 0. But the level E naught dash, which corresponds to L is equal to 1, splits into 3 sub-levels corresponding to ML is equal to 0, ML is equal to plus 1, and ML is equal to minus 1. The transition between these split energy levels now takes place according to the selection rules delta ml is equal to 0 or delta ml is equal to plus or minus 1. So the central line here corresponds to delta ml is equal to 0. The line to the right here, this corresponds to delta ml is equal to plus 1, and the line here corresponds to delta ml is equal to minus 1. Correspondingly, we have 3 spectral lines here. The single spectral line, in the absence of magnetic field, splits into 3 spectral lines which are equally spaced. The spacing between these spectral lines is called Zeeman shift. So the frequency shift is now given by d nu is equal to nu L, which is nothing but Larmor frequency, which is equal to plus or minus Eb by 4 pi m. To write it in terms of wavelength, first we'll write the frequency in terms of wavelength. We know that V is equal to C by lambda. Therefore, d nu is equal to minus C by lambda square into d lambda. Thus, d lambda is equal to minus lambda square into C d nu, or substituting for d nu here, we get this expression d lambda is equal to minus or plus b e lambda square by 4 pi mc. So equation number 11 and equation number 12 are the expressions for the Zeeman shift in terms of frequency and wavelength respectively. Thus, the vector atom model successfully explains the normal Zeeman effect. Thank you.